Hello guys, we are back with our next lecture. In this lecture, let us go through one of the most interesting concept, that is a degree sequence. So basically, whenever you want to ask a small question to your friend or in your examination, your faculty or someone will be asking these kind of small interesting questions, guys. Like they will be giving you a degree sequence and they'll be asking you whether a graph is possible for it or not. So if you observe here, 4 3 2 2 1 is a degree sequence. So they will be just giving you this sequence and they will be asking you whether there is a graph possible for this or not. So you will be assuming that okay, so this is the degree sequence. So you will be starting from 1 dot 2. So there are 1 2 3 4 5 vertices. Okay, so you'll be drawing this in this way. Then you will be starting with the highest or smallest, anything, it depends on you. So you'll be starting with 4, assume in that way. So from one point you will be giving 4 connections. 4. Okay, so we give. So after that, from one point you will be giving 3 connections. Okay, okay, so we give again from one point you'll be giving 2. So this is for 4 and this is for 3 and already this is for 2 and this is for 2 and this is for 1. So we have successfully drawn the degree sequence. Okay, yes. So in the similar way, if a large question is given, how can you solve it, and what is this degree sequence first? So how is it made, and whatever things we'll be discussing in this lecture. So basically, degree sequence is a sequence of numbers, that the numbers are nothing but the degree of the vertices of the graph, guys. Okay, so those are degree of the vertices of the graph, and those degrees are written in non-increasing or non-decreasing order. So basically, whenever you are doing some kind of programming, they will be using these words like non-increasing, non-decreasing. So most of the students will be confusing, like what is this non-decreasing or non-increasing? So the only thing that you should remember is increasing order or decreasing order is applicable only for distinct values, guys. For normal values or repeated values, you cannot say these are decreasing or increasing. So basically here the values are decreasing, right? So it should be decreasing order if there is no repetition. Hence this order is nothing but a non-increasing. So basically they are not increasing, right? So they could be constant. So that is the reason why it is called as non-increasing. Similarly here they are increasing, but there are some common things where they are equal. So it is called as a non-decreasing. Okay, simple logic to remember. Okay, so let us continue. So the arrangement of degree of all the vertices of a graph G either in the order of non-increasing or non-decreasing. So you are just adjusting, or you will be just writing the degrees. Okay, so this degree sequence is for this particular graph. So if you observe here, okay, so this is the graph, a small square with an arrow. So for this, if you calculate, here the degree is 2, 3, 2, 1, 2, 3, 4 and 1. Okay, so for this degree, I have just wrote it in this way, in a non-increasing and non-decreasing. Okay, so and we tried to draw it again, right? So we tried to replicate this as an example, right? So if you observe here there is a possibility of multiple different graphs also. So this was the question that the examiner thought of and he wrote the degree, but we solved it with the same example and we proved that it is possible with a different graphical representation, right? Yes. Okay, so I hope everyone got a small idea about a degree sequence. So in this lecture, let us continue with some more logical things which you can observe and say that whether the degree sequence is accepted, that is nothing but can we draw a graph for it? So is it possible or not? Okay, so same degree sequence can have multiple graphs. So that's what I was trying to explain you there. Okay, so degree sequence is correct or not is the question. So if you observe here he gave directly degree sequence, guys. He did not gave in terms of non-increasing or non-decreasing. Okay, that will also be fine in some kind of situations. So 2 3 3 5 4 4. Okay, so the one thing that you should remember is the degree sequence should always be even, guys. So you might be having a doubt that okay, how you are saying or why you are saying. So there is a popular formula that is nothing but degree is equals to 2 into edges, right? Yes. So if you find the number of edges based on degree, you need to divide it by 2. So if it is a odd, you will be getting x 0.5. X might be any number, 9.5, 10.5. So here we will be getting 10.5, right? So 10 edges is fine, but what is this 0.5? Is there a half edge? No. That situation is not possible. So using this small trick, if you add the total degree should always be even. So in any situation, if you find it as odd, you need to just say that that degree sequence is not possible and we cannot draw a graph anytime. Okay, yes. So similarly, one more trick to do is nothing but, if you observe here they gave it as 2 5 4 3 4. Okay, so if you add it, you're gonna get an even number. So you might be asking that how did I do that much fast? You might be having a doubt, right? So a simple trick that you can remember is adding two odd numbers will result in even. Adding two even numbers will result in even. So you always try to pair odd with odd. So if you observe here, I paired even with even and I paired odd with odd, and at the end I left with even. So at the end result will be even. Simple. And remember, even plus odd gives you odd. So here I added even plus even, so that gave me even. So I finally conclude that it is even. Okay. So but if you observe here, there is a small funny twist here. So here they told that here there are only 1, 2, 3, 4 and 5. So there are total 5 vertices, guys. Okay. And there is a funny thing is that the one vertex is having a degree 5. So if I told you in one of our lectures we discussed about this. So if there are n vertices, the maximum degree of a particular vertex can be n minus 1. But here the situation is false. But here the situation is reverse. It is saying that if there are n edges, there could be n degree. So let us try. So here it is 1, 2, 3, 4. And what about fifth? Fifth is not possible, right? So fifth cannot be possible. So in this way also you can say that it is not possible. So these are the two common tricks which are used to say whether the sequence is correct or not, or you can just blindly start drawing the graph also. So that will also work. Like just to start from greater to less or less to greater, the best option could be greater to less only, guys. Okay, yes. So I hope everyone got some basic idea about a degree sequence. So in the next lecture we will be going through Havel-Kami theorem. Okay, so let us meet in the next lecture. Thank you. Thanks for watching.